Okay, students, my name is Theodos Kazao, and I'm your physics teacher. Therefore, today we'll see about kinematics. In this section, we'll see about one-dimensional motion and two-dimensional motions. Therefore, first, let us see one-dimensional motion, that is motion in straight line. When we say motion in straight line, it's what? 1D. That's one-dimensional motion, either in the horizontal or in the vertical motion. Before seeing this, let us define what we mean by frame of reference. When we say frame of reference, a rigid body or a rigid frame of reference or coordinate system that can be used to measure what? The motion of an object is frame of reference. Therefore, every value depends on the frame of reference. And let us differentiate average and instantaneous velocity. When we say average, from the name, average means the taking two values and dividing by 2 by taking the difference of the two. Therefore, since it is a velocity, we can take the difference of what? The displacement between 2 pointers, and dividing by time gives us the average velocity. But instantaneous velocity is a velocity of an object at what? At some instant point. Some instant point. That means we see that here, velocity, average velocity, the total displacement or the distance traveled, specified direction divided by the total time taken. Therefore, since average is s2 minus s1 over t2 minus t1, that means the difference of the 2 point times divided by the total time taken gives us the average velocity. But when we see instantaneous, it's change in displacement over change in time, but at this time, as this change in time goes to 0, that means t2 minus t1 goes to 0. This one leads us to a limit of change in s over change in t, as t change in t goes to what? 0. This you'll learn this in mathematics on grade 12 about limit. But when we say lim as change in t goes to 0, that means the difference of the two values, the initial and the final, is approximately 0. That means much smaller. This leads to us to calculate the velocity of an object at some instant point. Therefore, the velocity of an object at some instant point is instantaneous velocity. And the other thing is instantaneous acceleration and average acceleration. When we say average acceleration, we will take the change or the difference of the velocity, that means v2 minus v1, and this change in velocity at a given time t gives us average acceleration. Therefore, average acceleration is v2 minus v1 over t2 minus t1 is the average value. But the instantaneous one is true. The same thing is true as the instantaneous velocity. Therefore, acceleration instantaneous is equal to lim as change in v over change in t, and as change in t goes to what? 0. That means the difference of the time is approximately 0. That means much smaller. For this reason, we are calculating, when we calculate instantaneous acceleration, you are calculating the acceleration of an object at some instant point. But the average one is between 2 pointers, or the value of 2 point velocities change gives us the average one. And the other thing is motion with constant acceleration or uniform accelerated motion. When we say motion with constant acceleration, the acceleration of an object, if it is constant or if it is unchanged, we can call that motion is uniform accelerated motion or a motion with constant acceleration. Therefore, we have some examples of uniform accelerated motions, but we will use for all these uniform accelerated motions these examples. When you use these equations, the first one measures displacement s, the second one measures what? Acceleration a, the second one measures the final velocity v, and the fourth one measures the time t, and the fifth one measures the initial velocity u. Therefore, s is displacement, a is acceleration, and v is final velocity, and t is time, and here u is initial vertical velocity, initial velocity. Therefore, these are the 5 variables we use in these 5 uniform accelerated motion equations. Therefore, since the variables are 5 and one is missing from each equation, each equation have how many variables? 4 variables. Therefore, if you are asked to calculate some questions by using these 5 uniform accelerated motion equations, you have 3 given and 1 required. Therefore, 1 is missed always. Therefore, you must calculate by taking the missing equation. For example, a driver of a train traveling at 40 meters per second applies a brake as a train enters to a station. The train slows down to a rate of how much? 2 meters per second. A platform is 400 long. Will the train stop in time? You are asked to calculate what? The time. Now, initially, the train is moving at what? 40 meters per second. Therefore, u is equal to 40 meters per second. And then applies the brakes of the train to stop in station. The train slows down at a rate of how much? 2 meters per second. That means the acceleration is what? Minus 2 meters per second. Since it is minus, because it's minus, it's decreasing or decelerating. And the final velocity, since finally the car is stopped or the train is stopped, the final velocity is what? 0. And you are asked to calculate t. T is equal to how much? Therefore, what is missed? The missed one is what? S. Therefore, you will take the first equation. We will need to find the stopping distance. Okay, you are asked to calculate the distance first. S. Therefore, to calculate S, what is missed? Time. The time missing equation is used. Therefore, v square u square plus 2s. And then finally, by rearranging, you are calculating for s, v square minus u square over twice of a. Finally, you got how much? 400. But the distance between the train and the station is 400. Therefore, it will stop at a time, because the train has a distance of this much, and to stop here's this amount of distance. Therefore, the train stops at a time. And if you are asked to calculate the time, you can use the time missing equation. One example of this uniform accelerated motion is free falling. Free falling is a body or an object showing all forces acting on it, and it can also show the size and the direction of the force. Therefore, initially at this point, at A, B, and C, we have 3 pointers, and this one is A, this one is B, and this one is C. And in A, when the ball or the object is released, after some time t, the object is released, there is an upward force which pushes the object, that is the air resistance. After some time, the air resistance and the force of gravity or the object moving down force becomes what? Equivalent. Therefore, at this time, or the velocity at this time which the object is moving is called terminal velocity. Therefore, terminal velocity is a velocity of an object moving down in a free falling body or in a free fall when the upward force, that means the air resistance and the force of gravity, is equivalent. Then after this terminal velocity, the velocity of an object will decrease, or it remains constant. If you are asked to do a calculation on the falling body, you will have to assume what? The resistance has been negligible. It doesn't have any effect on the moving object. Therefore, we will take a resistance is negligible. Let us take one example. A stone is dropped down a well. You hear a splash after what? 2 seconds. Work out the depth of the well. It says what? Dropped. Therefore, the initial velocity is 0. And the splash is heard after 2 seconds. And time t is what? 2 seconds. and you have an acceleration. The acceleration is gravity, that is 9.8. Therefore, you are asked to calculate the depth. S is equal to how much? What is missed? V. Therefore, you will take V missing equation, that is S is equal to ut plus half of at square. And this one is 0, therefore this one cancel out. And by substituting all the values, you can get this much. This much. Then approximately 0 plus, it's not minus. Approximately this one becomes how much? 20 meter depth. Here, we take one assumption. The assumption is the splash is hit as soon as when the dropped stone reaches the ground. That means ignoring the speed of sound. Ignoring the speed of sound. Therefore, our assumption that air resistance on the stone is negligible and also the speed of sound is so fast. That means we will hear the splash as the same time when the stone reaches the ground. Okay, the other thing is graphical representation of motion. We have two types of graphs, actually three. We will see two types of graph, that is displacement time graph and velocity time graph. We will see that, but we have another graph, that is acceleration time graph. Therefore, let us see first displacement time graph. In displacement time graph, we will represent in the y-axis the displacement, in the x-axis time. From this the slope of this one is the graph. Therefore, the slope of this graph, slope or gradient of the graph gives us what? Velocity. Therefore, we will calculate from displacement time graph velocity by taking the slope, or by calculating the slope, or by calculating the gradient of the graph. And always, if the graph is steeper to the displacement or the y-axis, it's faster. That means if you have one graph, such a like, and such a like, and such a like, A, B, and C, from these three graphs, which one is faster? This one is displacement time graph. Therefore, the faster one is which is steeper to y-axis. Therefore, C is faster than B and A, and B is also faster than A. Therefore, from these three, which one is slower? A is slower because it's not steeper to y-axis. This is because the distance is higher and the time taken is what? Short for C. But for B is larger time and the displacement is also small. Therefore, if the graph is steeper to y-axis, its speed is greater. We have one example here. What was the velocity of the journey shown in the graph? The velocity. We will take the gradient. Therefore, at this point we have what? 1 point, that is 5 and 30, and at this point we have another point 0, 0. Therefore, V is equal to S2 minus S1 over what? T2 minus T1. This one is the final and this one is the initial. Therefore, this one is time and this one is S. Therefore, S2 is 30 minus S1 is 0 over 5 minus 0. And finally, 30 over 5. This one becomes what? 6 meters per second is the final answer. The second types of graph is velocity time graph. Alternative way of recording a journey is velocity time graph. In this velocity time graph, we will calculate two basic pointers. The first one is by taking the slope. The slope gives us acceleration, and the area. Which area? The area under graph. We will give us what? The displacement. Therefore, if you are asked to calculate the displacement in velocity time graph, you will take the area under the graph. And here we have three types of graphs. Always the segment of the graph, if you subdivide, it looks like these three. The first one is horizontal graph. In this horizontal graph, as you see, the velocity is what? Constant. Since the velocity is constant, the acceleration is what? 0. Therefore, V is constant for this, constant, and acceleration A is what? 0. But here, V is what? V is constantly increasing, but the acceleration is what? Constant in this case and positive. But in this case, velocity is what? Constantly decreasing. Since it is decreasing, the acceleration is what? Constant and negative. negative. Therefore, since the acceleration is negative, this one is what? Decelerating, but this one is, the acceleration is positive, we can say it's what? An acceleration. Therefore, this is the interpretation of the graph. The slope of the graph is your acceleration, and the steeper to y-axis, this one is similar to the displacement time graph. If the graph is steeper to y-axis or steeper to velocity, the acceleration is greater, just like as we did before. For example, here, if the graph is steeper to y-axis or the displacement, its velocity is what? Greater. The same thing is true for VT graph. If it is steeper to, if you have another graph here at this point, since it is steeper to velocity, from this and this one have a larger acceleration because it's what? Steeper to y-axis. We have one example here. What is the acceleration shown on the graph? To do this, we have 2 points. For these 2 points, at this point we have what? 0 and 2, and at this point we have what? 2 and what? 8. Therefore, V is equal to acceleration is equal to S2 minus, V2 minus V1 over what? T2 minus T1. And this one is equal to, V2 is how much? 8 minus 2 divided by 2 minus 0. And finally, 6 over 2, this one becomes 3 meter per second square is the answer. And if you are asked to determine the acceleration, the displacement for this question, you will take the area under the graph. Which area? This area. And this area is irregular shape, therefore you must change by drawing a lines, and it looks like one triangle and what? One rectangle. Therefore, for the displacement is equivalent to area total. Therefore, displacement is equal to area 1 plus what? Area 2, because we divided into 2. You must divide as you wish. The answer is similar. Therefore, for area 1, for rectangle 1, area 1 is equal to base times height, and the base is from 0 up to 2, it's 2 second, times the height is from this up to this, it's what? 2 meter per second. Second is cancelled by second, and 2 times 2, it's what? 4 meter. And for area 2, it's what? Triangle, therefore 1 over 2 base times height, and 1 over 2, the base is how much? From this up to this, it is what? 2 second, times the height is from this point up to this point, that means from 2 up to 8, it's how much? 6 meter per second. Second is cancelled by second, and then 2 is cancelled by 2, finally you get how much? 6 meter. Therefore the total displacement is, area 1 is how much? 4 meter, plus area 2 is 6 meter. Finally we can get what? 10 meter is the total displacement. Okay, there is another example. Do this by yourself. Let us see motion in 2 dimension. That means motion in a plane. In this we will see about projectile motion first. In projectile, okay, this projectile motion is a motion when an object is propelled in space, or when an object is moving upward without an engine or without any motive force. We can call, or we can say, it's what? A projectile. In this projectile we have 2 types of motions, that is horizontal and vertical motion. In the horizontal motion, always the horizontal velocity is what? Constant. V horizontal is constant always. Therefore, in the horizontal motion, always the velocity is constant. And in the vertical motion, in projectile, the pattern on projectile, when an object is thrown upward, it moves up and it falls down. In this case, the V horizontal is constant, and the vertical velocity, when it moves up, it decreases, and at this, the maximum height, it's what? 0, and when it moves down, it's what? Increases. Therefore, this indicates that the vertical velocity changes, but the horizontal velocity stays constant. constant. And if you are asked to determine the maximum height, you can see the derivation, and this h max is calculated by using the equation that u square sine square theta over 2g. U is the initial velocity without resolved, or this is u, and when you resolve vertical and horizontal velocity, you can use the angle theta. Vertical velocity and v horizontal, v vertical is what? U times sine theta, and the horizontal velocity is u times what? Cos theta. Therefore, the initial velocity which we use in the projectile motion is u. That means it's not the vertical one. U is the initially an object is thrown upward. And the second value is the flight time. We have two types of flight time: the total flight time and the half flight time. If you are asked to determine the total flight time, you must use this equation. But if it is half, t half, you must use what? 1/2 of the total flight time. And this one is equivalent to u sine theta over what? G is t half. When we say t half is the time taken to reach the maximum height, or the time taken to complete half of a projectile. That means this one is the total projectile, and the total flight time is from this up to this point. An object which is flying in air, the total flight time, if you are asked to determine, you are determining the total flight time from this point up to this point. But if you are asked to determine half flight time, or the time taken to reach the maximum height, you are calculating this only, the half one, from this up to this, or from this up to this point. Therefore, you must take care of the equations. If you are asked to determine half flight time, you must use this equation. If you are asked to determine total flight time, you must use this one. The other thing is projectile range. Range is the horizontal displacement. And to determine this horizontal displacement, we must use what? Horizontal velocity and total flight time, the product of the two. And rearranging this, finally you get this equation. And by using trig identity, you can also get this equation. You can use one of the two depending on the given angle. If theta is, for example, we have one example here. Find the range of the projectile launched at an angle of what? 50 degree. And in the given, if it is sine 50 and cos 50 is given, you must use this angle. If but sine 100 and cos 100 is given, you must use the double angle equation. But here both are known, sine 50 and sine 100. Therefore, you can take sine to theta. That means in the place of theta, you can substitute 50. 50 is given. Therefore, 2 times 50, how much? 100. Sine 100. Sine 100 is 0.9848, and therefore 30 is u is 30. Therefore, 30 square is 900, and finally you get how much? You get 90.35 meter is the range. That means the horizontal displacement. There is also another equation which first you must find the flight time, and then if you are asked to calculate the range, you can calculate the range. This is another example. You can use one of the two equations. Okay, the other thing is maximum range. Range becomes maximum. As you see, when the angle is 50 degree, the range is such a like, and when it is 30, it becomes at this point. When it is 45, it becomes at this point. Therefore, from all, when it is 60, it is similar with what? 30 and 60 have the same range, and 75 and 50 also have what? The same range. But from all, 45 is different. Therefore, range is max when theta is equal to how much? 45 degree. In equation you can derive, when you substitute 45 degree, you can finally get maximum range is equivalent to what? U square over g. The sine value or the cosine value is cancelled out. Therefore, we can get a maximum range is achieved when the angle is how much? 45 degree. And when angles are complementary angles, if the angles are complementary angles, the range of the two angles is similar. For example, if you are asked to calculate the range of 30 degree projectile and the range of 60 degree projectile, you can get similar value because these two angles are complementary. If you add how much, they becomes 90. Therefore, they are complementary. That means sine and cosine of the two values are equal. And if it is 50 and 75, also what? Complementary. It is similar. Therefore equivalent. Therefore the range of 50 degree and 75 degrees equivalent. The range of 30 degree and 60 degrees also equivalent, and the ranges becomes maximum when theta is equal to 45 degree. And if the object is launched from some height from the ground, you must determine the range by using this equation. In this equation we have one new value, h. This h is the height which the projectile is launched. For example, we have one projectile here. As you see, the velocity of the object is 36 and is launched at an angle of 39 degree, and it's launched 1.6 meter from the ground, above from the ground. Therefore, u is how much? 36. We can substitute 36 cos 39 and 36 in the place of u, 36, and sine of 39 plus and radical of this 36 sine theta the whole square 2 times 9.81, and the height is how much? 1.6 meter. And finally you get the range of such a value. Therefore, if the object is launched from some height from the ground, you must use this equation, and if it is launched from the ground, you must use the previous range equations. The other thing is uniform circular motion. From the name, uniform circular motion is a motion at constant speed in a circle. This circle indicates the speed. It's not only the constant value is the speed. There is what? Radius is also constant. Therefore, when we say uniform circular motion, it has what? Constant speed, 1, 2, constant what? Radius. Therefore, projectile motion is not uniform circular motion because it doesn't have a constant speed as well as what? Constant radius. The other thing is angular displacement. Displacement in linear case we measure in meter, centimeter, but in angular we measure angular displacement in radians, revolution, and what? Degree. But the SI unit is what? Radians is the SI unit of the angular displacement measurement. And the relation between this revolution degree, this is 360 degree, revolution degree and radians. One revolution is 360 degree and 2 pi radians is equivalent to 1 revolution as well as 360 degree. By using this relation, you can change from degree to radian, radian to degree, revolution to degree, revolution to radian. Therefore, 1/8 revolution is 45 degree and pi over 4 radians, and so on. You can see this by yourself. And the other thing is angular velocity. Just like linear velocity v is displacement over time. In angular velocity is also what? Angular displacement theta over what? Time. Angular displacement here has a symbol theta, and angular velocity has a symbol of omega. Therefore, omega is equal to theta over t. But if it is one complete cycle, theta, the covered angle theta for one complete cycle is how much? One complete cycle, it's what? 2 pi radians. And for one complete cycle, the time is expressed as time period, and it's capital T. Therefore, the equation becomes 2 pi over t. This one is for one complete cycle. But if it is not one complete cycle, you must use this equation to determine the angular displacement. No, the angular velocity. The other thing is the relation between angular velocity and linear velocity have their own relation. And this relation is tangential velocity or linear velocity is equivalent to radian times angular velocity. Let us see one example. For example, the Earth take an approximate value of Earth to rotate or to orbit the Sun is 365 days. Calculate this angular velocity and tangential velocity if the distance between the Earth and the sun is this much. First, we must convert this day, this is time period, capital T. You must convert this to second, and when you convert, you got this much. And for one complete cycle, the equation of omega or angular velocity is 2 pi over capital T. Therefore, 2 pi is here and capital T is this much. Therefore, by dividing this, you got this much value. And to determine the tangential velocity, V is equal to what? R times omega. R is known, it's given 1.5 times 10 to the power of what? 11 times 2 times 10 to the power of what? Minus 7. And 1.5 times 2, it becomes what? 3 times 10 to the power of 4 meter per second is the final answer for the tangential velocity. The other thing is centripetal acceleration. Centripetal acceleration is an acceleration which always acts toward the center. And it's given by the square of the tangential velocity divided by the radius of the curvature. And by taking the relation between linear and tangential and angular velocity, you can rearrange and rewrite as also centripetal acceleration is equal to r times omega square. Therefore, a centripetal is equal to v square over r. Or you can also calculate by using r times what? Omega square, because v is equal to r times omega, and if you substitute this in the place of v, you can get this equation. The other thing is tangential acceleration. Tangential acceleration is an acceleration which is caused because of change in tangential velocity, and therefore a tangential is equal to change in t over time, change in v over time. This change in velocity is which velocity? It's the tangential velocity. The other thing is angular acceleration. Angular acceleration, just like tangential acceleration, because of change in angular velocity, there is an acceleration. That acceleration is angular acceleration, and it's given by alpha, which is equivalent to change in omega over change in time. Rewriting the 5 uniform circular motion for linear and angular case, you can replace v by omega, u by omega naught, t by itself t, acceleration by alpha, and the final one is se by what? Theta. Therefore, omega is final angular velocity, omega naught is initial angular velocity, and time is t, and alpha is what? Angular acceleration, and theta is angular displacement. Here we have two examples. Let us see one of the two. Here, find the distance traveled when the final angular velocity is 40 rad and the angular acceleration is what? This much. The final angular velocity is given 40, and the radian per second is the acceleration, angular acceleration. It's also given, and this change is at a time of how much? Okay, here it's below, therefore the 3 rad per second, and the time taken is, it's given, the time taken is 4 seconds to do this. Therefore, time is also given, and you are asked to determine theta. Which one is left? Omega naught is left. Therefore, the omega naught missing equation is theta is equal to omega times t minus 1 over 2 alpha times t square. That means this equation. Which one? This the fifth one. Because the first one misses what? Theta. The second one misses alpha. The third one misses omega, and the fourth one misses time, and the fifth one misses omega naught. Therefore, each one have a missing variable. Therefore, you can use that. And finally, by substituting, you can get how much? 32 radians. The other thing is radial force. Radial force is the force acting on a body moving in a circle, always directed towards what? The center of the circle. And this radial force is named as centripetal force. Therefore, radial force has another name, that is centripetal force. Radial force and centripetal force are similar, and radial acceleration is centripetal acceleration. Therefore, always centripetal force is acting toward the center, and which keeps the object in its circular motion. Therefore, the centripetal force always acts toward the center. This means the centripetal acceleration is also towards the center. The other thing is motion in a vertical circle. Motion in a vertical circle. Okay, in a vertical circle, we have three values. The first one is, this one is gravity, and this one is what? Centripetal force. This one is force of gravity. And the force of gravity and the centripetal force is both are down on the top, and both are in opposite direction. The centripetal force is up and the gravitational force is down at the bottom, and at the edge there have an angle of 90 degree, Therefore, for this reason, let us see one example to take the relations. Now, in this example, we are asked to determine the tension at this point, and at this point. For the net force to the center is given by the tension in the rope minus what? Tension in the rope minus the component of weight. Weight gives us what? F net or F centripetal. This one is the general equation. And this weight, since there is change in angle between the tension, the centripetal force and the weight, therefore it becomes what? T minus mg cos theta is equal to what? Fc. This one is the general equation. From this, depending on the value of theta, we have different equations. For the first, now F is equal to mv squared since it is centripetal, and for the object at the bottom here, since the weight is down, there is no angle, theta is how much? 0 degree. Therefore theta is 0, cos 0 is 1. Therefore our equation for the bottom becomes T minus mg is equal to what? Mv square over r. This one is for the bottom. And for the top, the angle is 180 degree. Therefore, since it is 180 degree, it becomes what? -1. This negative sign makes the equation this plus. Therefore, it becomes what? T plus mg is equal to what? Mv square over r. This one is for the top. And at this position, that means at the mid position, the angle is how much? 90 degree. It makes 90 degree with the tension. Therefore, since it makes 90 degree, cos 90 is 0. Therefore, it's cancelled out, and we have left with only tension. Tension minus 0, it is tension, which is equal to what? Mv square over r. This one is at the midpoint. Therefore, at the top, T plus mg, mv square over r. At the bottom, T minus mg, which is equal to mv square over r. And at the midpoint of the top and the bottom, T is equal to mv square over r. By using these equations, you can determine whatever you are asked. Most of the time, you are asked to determine the velocity. Therefore, you can calculate the velocity by using such relations. The other thing is motion of satellite. In this motion of satellite, we will see only Newton's law of universal gravitation. According to Newton's, between two celestial bodies, there is an attraction force. This attraction force has a direct relation with the product of the two mass. F has directly proportional with m1 and m2, and it has an inverse square relationship between the separation distance. That means we have two masses, m1 and m2. Between these two, there is what? A separation distance r. Therefore, the product of the two mass has a direct relation with the force, and it has an inverse square relationship with the separation distance. Therefore, you can cancel out this proportionality and add one constant, that is F is equivalent to G times m1 m2 over what? R squared. Therefore, this G is the proportionality constant, which is called the gravitational constant, and given by this value. There is one example. This example is already done. Therefore, see by yourself. Let us see the final point, relative velocity. When we say relative velocity, expressing the velocity of an object relative to what? Some point. Therefore, the vector difference between two velocities of an object is relative velocity. When we say absolute, the velocity of observer from stationary frame of reference. Therefore, the frame of reference, if it is stationary, you are recording or giving absolute velocity result. But if the frame of reference is not stationary, if it is moving, we are expressing what? Relative velocity. And this relative velocity have property depending on the direction of the moving bodies. If both are moving in the same direction, if they are moving in the same direction, you must take the difference of the two. This VBA means velocity of B relative to what? A. If both are moving in the same direction. But if they are moving in opposite direction, velocity of B relative to A is equal to what? VB plus VA. You must take the sum. And if there is an angle or if they are perpendicular, you must express your velocity first in terms of vector. That means in terms of ijk. After that, you must subtract and add. If it is addition, you must add. If it is subtraction, you must subtract. And finally, to determine the magnitude, you must take the Pythagoras theorem. And to determine the angle, you must take what? Tan inverse or the trig identity. After that, you can determine the final direction as well as what? The magnitude of the vector. This is all about unit string. Until next time, have a nice time.